Assalamualaikum warahmatullahi wabarakatuh. We are from Group J and I'm gonna demonstrate on our project which is called LLM4Healthcare. So what is LLM actually? I'm gonna explain briefly what is LLM. LLM is machine learning models that can comprehend and generate human language text, which is called large language model. Large language model is actually like ChatGPT, Bard, Llama, Bing Chat, and so on. So, what is basically a problem training an LLM? So, actually, training LLM, as you know, we dealing with a very large weight. We end up dealing with a really big weights actually. This raises a whole bunch of problems here. So firstly, you need a lot more compute to train, which is we need a bigger GPU. And secondly, the file sizes become huge. So this is where the idea of PEF, which is parameter efficiency fine-tuning, comes in. So one of the technique we use in our project is actually LoRa. LoRa is low rank adaptation, which is a method of fine-tuning method introduced by a team of Microsoft researchers in 2021. Uh, in this diagram, you can see LoRa. What it does is actually it converts pre-trained weights with trainable parameters to be used in our model. So what LoRa does is actually allowing you to fine-tune only small number of extra weights in the model. Here is our code. We run in Google Colab. So for the first cell where we install all the necessary packages like datasets, transformers, path, bits and bytes, accelerate, tensorboard, and also JSON lines. So this package, dataset, transformers is for this one is for to access our dataset, which is we got from Kaggle. Transformers is where we want to access the pre-trained model, which is Gamma later on. Bits and bytes we use to utilize our device, which is we set the parameters for training later and also accelerate. Tensorboard is for logging and visualizing training progress later. And then JSON lines is where I used to create a new dataset, which I filter the dataset that I use from Kaggle, and then I create a new dataset for training. So is where I log into my Hugging Face account using the token that I have created in Hugging Face. And here is where I we load the base model, which is we using Gamma 2B. We use Gamma 2B is actually because it is more smaller than Gamma 7B and all other base model. Actually, loading this is we already using almost all of the system RAM, so we unable to use other better base model for our training. So there is a weakness in our project actually. So it's where we loading the model, and as you can see here, this is the models of the base model for Gamma. Here's where we try to input the text question and answered, and it is answered by the Gamma. Here's the output, and in this cell where we freeze the original weights from the Gamma, and here is where we setting up the LoRa adapters. So as you can see here, there is 1430332 trainable parameters, and 2520475648 of all available parameters. So there is only 0.567 trainable parameters that we can train later on. So here is where we import all the packages: auto model, focus LLM, auto tokenizer, bits and bytes, configuration, and so on. This is where I load the dataset. I upload the MedQuad dataset into my Hugging Face account so that I can access to using datasets. So I load the dataset using split train, and I filter the dataset using focus area. If there is no focus area, then we don't use the row, we reduce the row. And here's the filtered dataset. It comes with question and answer only. So here's where we created the dataset using JSON9, and here is the dataset that we have created that I already upload into my Hugging Face account. And then we only load 1000 rows, as there is so many rows, so many datasets that we have to deal. It needs a bigger GPU, so we only able to train 1000 dataset in a time. So here's where we set all the parameters: LoRa parameters, bits and bytes parameters, training arguments, and also SFT parameters. This is the name of the model, and rank we set to 4, alpha we set to 16, and dropout, LoRa dropout we set to 0.1. For bits and bytes we use 4-bit, and D type we use float 16, and quantization we use NF4, and we disable the double quantization, which is it need a bigger GPU. So for the training arguments, we set the epochs to 1, only 1, because we only want to train for one epochs. We disable the FP16 and PF16. The batch size per GPU for training, batch size we using 8, and evaluation batch size also 8, and the gradient accumulation steps we set to 1, and we enable the gradient checkpoint. So learning rate, the optimizer we using is AdamW, and learning rate we set to 2e minus 4, and the weight decay 0.01001, and this is the optimizer to use later for training. Patch AdamW 32-bit. The max steps is actually unnecessary because we already set the epochs to 1 just now, so we don't need to set the max steps. Therefore we set to -1. The warm-up ratio 0.03. This is the warm-up ratio, and the save steps and login steps we set to 25. For training later, there is a checkpoint for every iteration. We set to 25. This is the SFT parameters. We set the maximum sequence length to 64, and the packaging we enable the packaging, and device map we set to auto, because later is easy for the training to use the device, which is the system GPU and also system RAM and also GPU RAM. This is where to monitor GPU usage using Tesla T4. This is our GPU name, and then after setting the parameters, we load all the parameters into the configurations. So this This is for the QLoRa, computing type, the use for bit and so on, the bits and bytes configuration. And this is for checking the compatibility. So this is actually for us to check whether our GPU is compatible to use bfloat16 or not. So our GPU is not compatible, so we don't use the bf16. This is where we load the base model again, which is gamma. This is where we load the LoRa configuration, the LoRa alpha, dropout, rank, and the target models. Here is where you can see from the models where we print the gamma model just now. This is it. QProch, KProch, PProch, and so on. That is for the LoRa. And then we set the training parameters for training data, the training epochs, the gradient, the training batch, learning rate, and so on. This one is for training. And then lastly we set the supervised fine-tuning and the model, the train dataset, the path configuration dataset, and so on. And here's where the training begin. So as you can see here, it runs for 1 epochs. There are checkpoints, which is 35 steps for every training. So as you can see here, the training loss decrease, meaning that it is good because the training is occur. So here is where we visualize the training. So you can see the training loss going down, indicating very good. It's just a little fluctuation, indicating overfitting, which is we need to aware of that. And here is where the inference we created for our project. So firstly, we input our question, and then it will answer. This is not very good actually, because it keeps repeating the same answer. So this one indicates overfitting, so we did a better training for this model. So we need a bigger GPU next time for the future. And we also try to ask different question. This one, it answers really well, which means the training is successful. And this one is how to prevent high blood pressure. This is the output. Very good also, it answers very well, very detailed answer. So that means the training is successful. And that's it. When we input exit, it will output goodbye to quit the chatbot. So that's it for our project. So for the future enhancement, we will try to use a bigger GPU so that it can train better, and also a more friendly user interface for our chatbot. That's all. Thank you very much.